Let's now look a bit closer on how hydropower plants can be characterized. Two important parameters to describe the availability of a technology in osmosis are the capacity factor and the availability factor. The fact that a plant exists does not mean that it can generate all of the time. For instance, a hydroelectric plant may be available, but there might not be sufficient water available to reach its rated output. In osmosis, the capacity factor indicates the availability of a technology in a specific time slice. That means it indicates the share of the actual possible production of the total theoretical production. This can depend, for example, on the resource availability, example, water availability. In comparison, the availability factor indicates for how much time of the year the power plant is available to produce. The parameter is commonly used to indicate the time that is needed for maintenance. How a hydropower plant operates depends heavily on its water supply. Many plants do not have enough water to operate anywhere near their full capacity on a continuous basis. Lakes and man-made reservoirs used for hydropower come in all sizes, holding enough water for as little as a one-day supply or as much as a whole year's supply. A plant with a reservoir that holds less than the annual river flow may change its operating style depending on the season of the year. For example, the plant may operate as a peaking plant during the dry season, as a base load plant during the wet season, and as a load-following plant between the seasons. A plant with a large reservoir may operate independently of wet and dry seasons, such as operating at maximum capacity during peak heating or cooling seasons. The graph shown indicates the flow rates of the Nile River. In yellow, the White Nile. In blue, the Blue Nile. And in orange, the main Nile. Run-off river power plants on the White Nile are producing almost a constant output due to the constant water availability, whereas on the Blue Nile, and therefore also on the main Nile, a strong seasonality can be observed. This would then also be reflected in the production pattern of run-of river power plants on these rivers. However, reservoirs allow to shift the production by storing the water and using it at a later point for power production. In the here shown table, we have a summary of technical performance and costs parameter. It is distinguished between very small, and large hydropower plants. Hydropower plants have longer technical lifetimes than most other power generation technologies. The capacity factor is of course strongly depending on the location of the power plant. Investment costs are often also referred to as capital cost and consider the cost for infrastructure, technology and installation. The O&M costs are the fixed costs assigned to the operation and maintenance of the power